Data availability with Layer 2 is one of the most interesting research topics among developers. If you are interested to have a sneak peek of what's expected on Ethereum network in a few months down the line, continue listening. Welcome to PEEPanEIP episode 96. I'm Pooja Ranjan, here with another interesting topic on protocol research with a very special guest from the Ethereum developers community. Today, we will have an overview of KZG ceremony, a trusted setup required for EIP 4844. To provide an overview on the topic, we are joined by Beekhuizen, the KZG ceremony coordinator and a researcher at Ethereum Foundation. Welcome to the show, Carl.
Hi, Pooja. Thanks for having me on.
First of all, congratulations for the announcement of the ceremony date. I hope to have a high-level overview of EIP 4844 and learn more about the KZG ceremony today with your talk. It would be interesting to probably start with a brief introduction and how you joined the Ethereum community.
Yeah, sure. That sounds like a good plan. I got started in the Ethereum community about 4 years ago. A friend of mine had started making a bunch of money doing some weird crypto things, which I had no idea what was happening there, but a bunch of money sounded cool to me, so I had to look up what this was all about. Anyways, the more I looked into this, the more I was like, hey, this is kind of interesting. There's some interesting problems and there's some cool protocol stuff happening, but it didn't really grab me. And then I saw all the proof of stake work happening. At the time, there was a lot of work on EIP 1011, which was the Casper proposal for proof of stake as a smart contract. Anyway, the requirement was 1500 ETH, which I did not have. So I came up with complicated solutions for basically what we call today liquid staking. But the idea being basically I could split up this 1500 ETH between myself and my friends. And as a result of all of this, I started solving a lot of interesting problems around consensus and networking and looking at how the database side of these things work and hashing systems or whatever. And then very quickly, I realized I was solving all the same problems that were like problems that needed to be solved at the protocol layer. So I was working on very similar problems to what needed to be solved at the Ethereum level. And when I realized that the EIP 1011 wasn't going to be a thing, and that we're still years away from actually making this happen, I basically ended up making the switch into full-time research to work on the same things, but just sort of one level deeper where it was at the actual protocol level and solving those problems. And since then, I've been doing research with Ethereum Foundation. My specialty, I guess, if I have such a thing, is generally on the projects that happen slightly to the side of the protocol. So this KZG ceremony is a good example. The Launchpad, lots of things around wallet standards and those kinds of things. So I'm always sort of both touching the main specs and then branching out into these side projects.
Getting into Ethereum blockchain with an interesting way, like getting to know more about crypto and that get to know about protocol is really interesting. And I remember the time of the 1500 ETH proposal when it was there at the time of when we were having the ghost proposal. It was really scary, but thanks to the development team, it's not that big for staking as of now. Yeah, right. So I'm super excited to learn more about it. Maybe we can start with screen sharing and presentation.
Okay, that sounds like a great plan. Let's do that. So I think today a good place to start would be explaining why this is all needed. So digging into EIP 4844, Ethereum's vision in terms of how to scale has changed a lot over the years. And one of the big realizations is that we can use L2s to do a lot of the scaling for us. And trying to make L2s practicable has been something that's been a struggle for a long time until the idea of rollups sort of came about, both ZK and Optimistic. And now we have all these with this concept role list, we have the ability to dramatically scale the compute that's available for Ethereum, which is absolutely fantastic. But the problem is a computer without much storage isn't very helpful. Currently we're limited to the blocks as we see them on Ethereum right now. And so even if you have these rollups, which could handle massive amounts of data, the rollups need to put their data somewhere. And if they just put it on Ethereum right now, then we don't have nearly the scaling that's necessary. So the idea behind EIP 4844 is to provide this data scaling. So the way this data scaling works is you take a bunch of commitments, a bunch of data blobs, which is the transaction data from rollups. It could be JPEGs of your cat if you so wished. The protocol doesn't really care, but the idea is basically you take these blobs and we commit to those blobs. So much like we use Merkle trees or Merkle Patricia trees or whatever to commit to the data on Ethereum right now. A KZG commitment is just another commitment device where we like bind ourselves to these data blobs. And so after a block proposer does this, the validators who are assigned to look at that block check whether this data is actually available, whether this data exists, that this block proposer has, or this block proposers put the data out there such that everyone can download it. And then the idea is that if they see that this is the case, then only do they attest to the data, which is part of their current roles. It's just like an additional role as a validator. Now you're going to be like, do I see these data blobs coming in? These data blobs aren't actually a part of the chain. They're only committed to on the chain. And the ties we have between them come via the commitments and then the validator saying that this data is actually around. And once they've done this, validators store this data and make this, like provide this data to whoever needs it, to the network. So if you are using an L2 and you want to check that your transaction's on chain, you should be able to find your transaction in these blocks. The L2 sequences are going to verify that all this data is there, and the validators are just going to provide this data out of their own local storage, much like they can serve blocks now, to those who ask for it. And then a little while later, the validators take that data and they throw it away. So there's like a sliding window of the data that validators are storing at any one time. And after this sliding window is passed, they're no longer responsible for providing this data. And the idea here is to prevent the storage requirements for validators from blowing up massively to handle this extra data that come in the form of these blobs. This is a really useful thing because now we can make these blobs really big, but because you only have to store them for such a short amount of time, it's like really doesn't add much load to you as a validator. So why do we have like we have this commitment mechanism? What's wrong with Merkle trees or any of your other favorite commitment things? And it comes down to this chart, which Vitalik posted on ETH Research a while ago, plus I guess some modifications for myself. But the idea here is basically that we need a commitment scheme that is very easy to calculate, very easy to verify. It would be nice if it has some benefits in terms of like if you have a commitment and another commitment, if you could combine them in some way really efficiently. And KZG provides us all of these things. And in addition, I think something that a lot of people, some people overlook here is that KZG commitments are the sort of only commitment available to us that work nicely inside of Snarks. That have these other properties. If you use hash-based commitments, they just become very expensive. The downside for KZG here is that it requires a trusted setup. So trusted setups, they're never good. Ultimately, if we could avoid them, that would be ideal. They add attack surface to your protocol. They change some of the trust assumptions you've been thinking about. So when you need them, A, you must be really sure that they are something that your protocol needs, and B, that you introduce them in a way that's minimizes the amount of trust required here. So the goal here is that we want to change this like trust assumption from like some of the early trusted setups where it was 6 people all together in a room who did some fancy computation. And there's some interesting stories to hear about some of the early Zcash setups. But basically where there were some few people who in essence you had to trust them to try scale this out to reduce these factors. So like, what are the major concerns here? Concerns are that you have lots of people. So you have very few people and you have to trust, say, 1 of 6 people or 1 of 10 people. That's not ideal. So ideally we would have like way more people participating. Lots of these implementations are like really complicated pieces of software that are very hard to write, et cetera, et cetera. So our goal with the KZG ceremonies trusted setup here is to try and minimize all these things. So there should, like, the idea, we're hoping to scale to thousands of participants, and we've really put a lot of effort into like make it easy to write your own implementation and hopefully participate quickly. So this interface is at ceremony.ethereum.org, and from here you can basically just in about 15 minutes or so contribute yourself to the ceremony with like no prerequisites in terms of signing up or needing to basically think through any of this process. And the idea here being that we want to make it as easy as possible. We'd love to have like anyone, no matter their technical background, if they're a part of the Ethereum community or not, just part of the wider tech community that find this an interesting project, that they can contribute easily to the ceremony. And that's sort of what we provide here. So I have this graph, which is sort of my my little like pet theory here, or my goal for that, and that's that I would like the ceremony to have more participants than we have points, which is a completely arbitrary and not really helpful thing. But I would really like to see that ultimately we have like tens of thousands of participants, but the ceremony is so small that we only have a few thousand points, which would mean that the file is mostly like showing who contributed. The like ultimate file that comes out of the ceremony, the transcript, is going to be mostly like, here's the list of people who contributed, and then like a tiny like add-on. It's like, oh, by the way, here's the output you actually cared about. Because then it's not like you have to trust a single people or a few people. It's that in order for something to have gone wrong in the ceremony, we needed to have basically everyone collectively coming together, recombining their secrets and reconstructing this like master secret together. And with this many people, it becomes very hard for this actually to be a thing that happens. There's just, you need a single person to be honest amongst this group. And then as long as they haven't stored the secret, then we know that this entire ceremony is safe. But it goes one further, and that's because like for the average person participating in this website, you don't just see the secret. The browser is sampling some randomness in the background. It's doing a bunch of extra calculations for you. So in order for you to have revealed the secret, you'd actually have to have taken apart, like you need every user to take apart the code they used to like extract out the secret and then to post it. So by scaling to lots of people, it makes it very unlikely that this is the case, and basically eliminates or reduces a lot of the trust that's required here. The second thing is that like code is never perfect. So although that implementation I referred to earlier has been audited and has had a lot of eyes on it, you never have guarantees. So just like if Ethereum EL and CL are written from like a specs first standpoint, like first there are some specifications and then ultimately there are multiple clients that implement it. The same is true for the specification for the ceremony. So it's written just in Python pseudocode, much like all the other ones are. And the idea here is to have like a minimal spec that is really, really easy to implement. And lots of decisions have been made to like have worse performance in terms of how the ceremony runs, just to make it like easier for people to participate in. And then hopefully this allows us to have multiple implementations in multiple languages using multiple compilers. So we like eliminate, like, I don't know, there's a Swiss cheese model of security where it's like, if you have a failure at one level, one hole in the Swiss cheese, and another level where they're like different holes, they don't necessarily line up. So by stacking multiple different ways that it could fail, if they're like uncorrelated or low correlation, then you make the chance of like all these cascading failures happening very low. So how does the ceremony actually work? So the idea here is that each individual, ultimately the ceremony wants to generate a secret and then some like mathematical variations on the secret. And the secret is just a number. So the way this works is we get multiple people to each contribute their own bit of randomness to the number. So in this case, the yellow person has contributed 3 to the ceremony, and then the blue person comes after them and they mix in their 5, which gives us like a new total secret of 15, which now note is like different to both yellow and blues. And then finally, we can have another person adding in here, mixing in a 2, which gives us 30, which is like, now this is a secret that neither 3, 5, or 2, these 3 people knew. And that sort of like represents all of their randomness or their contributions together. But there's a problem, and that's that like, if we just have these numbers, then everyone could read, oh, the secret's 30. So these secrets aren't like, we don't actually have a secret as a plain text number. It's an elliptic curve point on the BLS 12381 curve. And this is the fundamental to how KZG commitments work, is they require these committed collection of points. And then this is like what the output of the ceremony is. So by having everyone mix in their little bits of the secret privately, we get to this like combined secret, which no one can know, and is hidden using the same math that we're already using all over the place in Ethereum. So there's one other step here, and that's that in this naive, or in this previous thing, is that the final person or some of the earlier people could do the math incorrectly, or try cheat, or delete someone else's contribution or something like that. So we have this role called the sequencer, who's this centralized entity who checks that all the files and contributions are correct. So after each participant has like tried to add to the ceremony, the sequencer, like you send the file back to the sequencer is like, oh, hey, that seems valid, or no, that's like, that does not seem right. So, I mean, I mentioned the scary centralized word, and like, now it sounds like the sequencer's got all sorts of powers. So what can the sequencer actually do? And in essence, the primary malicious things it could do outside of just crashing are censoring contributions. So you could you could contribute and everything's going fine, and then you try to send it to the sequencer, and then when it comes to the verification step, the sequencer is like, oh no, there was a mistake in your contribution, it's not valid. When in actuality it was valid. And the second thing the sequencer could do is it could just simply not give you a turn. When you try contribute, the sequencer could just never allow you to do so. But there are like 2 easy mitigations to this, and one is that whenever you hand over some information to the sequencer like returns an acknowledgement which signs this. So if the sequencer were to like say, oh, what you sent me is invalid, you can give them this, well, you have a proof that the sequencer was lying. And in the second case, which is that the sequencer is just not giving you a turn, they're trying to censor you from starting this whole process, we can circumnavigate this by just starting with a, you could just join again with a VPN or Tor, and a new Ethereum account, which I'll get into a moment, into how the Ethereum accounts play into all of this. So I mentioned that there are these implementations that are like speaking to the sequencer to try like contribute. So what exactly is like happening through this whole process? So the first step is to sign in, and that's just because we need like a sort of anti-sibyl thing. We don't want the entire ceremony to just be basically DOSed by everyone trying to contribute to fake files. So there are 2 options available for this. One is sign in with Ethereum, where you can join and contribute with your normal ETH account, which is, I think, how most of us have established identities within the Ethereum space. And then the second is GitHub, if for like those community members who maybe don't have an Ethereum account or don't meet the minimum nonce requirements, which I'll touch on in a sec. So what does this actually look like? We have this notion of a lobby. So after you've signed in, you'll get put in a lobby, and then everyone in the lobby just keeps asking the sequencer if they can contribute. So here, as you can see, the yellow person is actually, it's their turn to contribute, and they are working on the powers of Tau. And these other people are asking like the sequencer, hey, like, may I contribute? And the sequencer is like, no, sorry, someone else is working on it. And then everyone just keeps asking like, what about now? Can I contribute? And then when this other person is finally done contributing, they'll be like, sure, here, like, here's the file. And then it'll be your turn to contribute there. So this is sort of how we handle lots of people wanting to contribute when this process is like fundamentally sequential, the contributing to the ceremony. So, I mean, earlier on I had this nice example with mixing of colors and people, but like, how does the math really work? That seemed a little bit overly simple, and what are the actual requirements here? So what we actually the ceremony and many ceremonies establish what are called powers of Tau. The powers of Tau here are some secret. This is the number we're referring to earlier, and then the secret squared, and then cubed, etc., etc. And we have many, like a series of powers of this, all encoded as elliptic curve points. And so this is like the ultimate thing that we'd like to get out of the transcript. So how do we go from this requirement to what we actually have, which is you? So the sequencer will send you the files when it's your turn to contribute, and then you, or more specifically your computer, will come up with a secret. This is some randomness that you're gonna hopefully destroy afterwards. And then you perform some mathematical operations. So you here calculate powers of your secret, just normal integer multiplication that you're doing here. Well, finite field. Anyways, and then you do element-wise multiplication. So you take the first power of your secret and multiply it by the first power in the powers of Tau, and continue this on until you've multiplied each of these out. And this basically, because elliptic curve math is linear, multiplies your secret and mixes your secret with the secrets that came before you, the existing powers of Tau. And this is how you can sort of build on these powers that already exist. And then you send these powers of Tau back to the sequencer, which verifies things. This looks awfully complicated, and there are a few pairing equations all over the place here. But the top is just information on what you basically send back the sequencer, and then the sequencer, using this information, checks two things. One is the update check. So like, did you honestly take the powers that were given to you and mix in your secret correctly? And then the second check it does is like, are these actually powers? Like, is this consecutive x squared, x cubed, moving up further? One further complication is that the ceremony is not actually one ceremony, but it consists of 4 sub-ceremonies. So it's 4 ceremonies parading as one. As a user of the ceremony, this is totally opaque to you. But under the hood, this is because one day in the future, we may wish to further scale the data that we make available via these via 4844, or when you scale up to full DankSharding. And so we may just simply need more points, more elliptic curve points to perform this math. And this ceremony is so cheap and easy that we can just have more than we need. So ultimately, in the 4844 specifications right now, you only need 4,096 points. But no matter what our requirements are, we should be good, because we have another few orders of magnitude here available to us. So like what's up with the sign-in earlier, and that's that we need some kind of anti-sibyl mechanism. As I mentioned, if we just if there were no requirements and anyone could just walk up and join, Then we could have like bots just spamming the sequencer, contributing and preventing legitimate users from like you or I from getting involved in the ceremony. So there are two ways that we verify this, and one is signing with Ethereum. So it gives us some additional benefits, like we can give co-ops to people, and after participating, and it enables something called double signing, which I'll touch on in a second. But basically, the requirement here is that you have at the launch of the ceremony on Friday the 13th, you have a nonce of at least 4. And if you're going to use GitHub, we just check that your account was created before Friday the 13th. For similar reasons. And the goal here is not to be perfect. So we could have someone contributing 5 times or 10 times if they had many accounts lying around. But it just needs to be good enough that it isn't entirely full of these spam things, and honest users can get involved. So these targets are intentionally set low enough that average members of the community should be able to, or most members of the community should be able to participate. So how does this double signing thing work? This is an extra step of verification, which allows both people who participated in the ceremony and the sequencer and the transcript afterwards to like further prove what actually happened. So if we say we have Pooja over here contributing with Ranjan.eth, and that's what she when she signed it with Ethereum, that's what she used. It will ask her to both sign it with Ethereum and to sign her contribution to have an ECDSA signature, standard Ethereum signature of the contributing. And then we actually use the secret as a private key to sign the Ethereum address, so Pooja's address, which has this like other effect of like verifying that really Pooja's claim is legitimate. So when we put this in the final output of the ceremony, which is what we call the transcript, we can see that Pooja did participate, and we can prove that it really was her because she signed this contribution with her Ethereum address, and if she's the only one who could have made this claim because she has this account, and the counter to that is the ceremony is verified that this really was her contribution, that she participated. So if Bob, after who didn't participate in the ceremony, wants to like check if they trust the ceremony, and if the ceremony output was legitimate, their process would be something along the lines of, hey, I trust Pooja. She seems like a reasonable person who wouldn't have saved and then revealed her secret. So that means that this entire ceremony will be safe if she contributed correctly. We know her contribution is included because we can see her contribution in the transcript, and it has the signing characteristic. And you further check that the powers of tau were correctly calculated, basically that there are a correct set of powers and that everyone else his participation was included and that Pooja's wasn't excluded after that. And then based on this alone, you should be able to, Bob should be able to trust this ceremony. So to touch on some other aspects, we are really trying to encourage people to write their own implementations. So as mentioned, this came from specifications first. It really is like we've stripped out all of the complexity. There's no weird, funny ZK math. It's a few elliptic curve multiplications, and that's it. So it's actually quite funny. Marius from Geth decided to implement this with a friend at ETH Prague at the hackathon, and thought this would take them the entire hackathon, and they were done the core protocol within an afternoon. So it really is a simple thing to implement. So highly encourage anyone who's got some coding capability to just write one for themselves, because it's easier to trust then. And The second thing is we offer grants to people who would really like to dig in further and maybe write a more robust implementation with a better documentation to try offer alternative ways for other people to contribute, or maybe in some specialized language, etc., etc. I've even been encouraging people to roll their own crypto in this case, which is not something you should ever do. But what I mean here is writing your own crypto implementation, because A, it would be a fun thing to do, I think, for many people, and B, it can't really go wrong, because if there is a bug in this, beyond leaking your local secret, but if there is a bug in your contribution, then the sequencer will just be like, hey, no, sorry, there's a mistake here. And so you can't really harm anything by doing this, and you could really then be sure that your secret's unlikely to be leaked. Another thing here is crazy contributions. So we're trying to really encourage people to come up with wacky ideas to both create entropy and to make sure that the secret wasn't destroyed, and to try convince other people that's the case. So on the bottom left there, that's a picture from the ZK sapling ceremony, where these two basically used a Geiger counter on some radiation material that they extracted from Chernobyl, and extracted the secret from all of this while being in the air, to make sure that there's very unlikely that the entropy is being biased by other hardware outside. And this the other image in the top right here is an interesting one from Mario Havel, who is it's got these accelerometers inside of a little ball that he's going to give to his cat, who's going to knock it around a bit, and he's going to use his cat to create some entropy. So all sorts of weird and fun ideas. So if you'd like to do that, would also be happy to fund that, those kinds of projects, and help people workshop ideas for that as well. So when's this all been deployed? So on Friday the 13th, the ceremony goes live. And then anyone's welcome to contribute via whatever mechanism they want. At the end of this month, the grant, the end of January, the grant applications go live as well. Sorry, that's the deadline. So if you want to get a grant in, please apply before then. And then after 2 months, so on the 13th of March, 2 months after the start of the ceremony, we're going to close the ceremony for the most contributions. And then we're going to allow for people doing these weird and wacky contributions to do their thing, in case we need to allocate them. Maybe they need a day to perform what they want to do. We just have a bunch more time to allow people to do this. And once everyone there has contributed again, we'll go back to allowing normal people, the people who aren't trying these weird and fun contribution mechanisms, to be involved again, and it'll be open again for normal contributions right up until the launch of 4844. So the idea here would be that as soon as the client devs indicate that they're ready for 4844 to ship, with 1 month or so lead time, we can shut down the ceremony and give this final output to the client devs so they can bake it into the clients. And yeah, I think those are all the slides I have.
Awesome. This was a great presentation. I really loved you using images instead of heavy text in the beginning of the presentation for the concept, because I think that the concept behind is way more encrypted for novice users. And yeah, also thanks for sharing the grant information. I hope the QR code that you have shared in the slides will provide more information about how to apply for the grant.
Yeah, no, hoping so. Thanks.
Yeah. All right. We have received a few questions from community, but I see there are some participants who have joined already. So I'd like to open the floor for people on the call to maybe share any questions they have.
I can ask a question. Is there any reason why you choose the VLS12381 curve?
That is a good question. I think it's because we have very good implementations of it already. It's already baked into consensus layer clients. I mean, there are some alternative curves which could work really nicely here as well. Some of them potentially a little bit faster, but I don't think we have like the robust infrastructure, and it would potentially delay things to do that. Also, it would be like another set of dependencies for all the clients. So I think it's an answer of being sort of good enough for this use case.
Can I have a question?
Of course.
Okay, thank you for the beautiful presentation, first of all. I wonder what is the idea behind the contribution signatures? I mean, why do only Ethereum users generate ECDSA signatures on contributions? Why do not the other users with GitHub credentials sign the contributions?
So the issues here is that there's like the GitHub's really supposed to serve as a backup for people who aren't able to use Ethereum credentials. Ultimately, it becomes very hard to prove things about GitHub because within GitHub there aren't established keys for everyone that could do such signing, and you can come up with complicated systems which use Git gists where you publish pub keys and those kinds of things. But then ultimately we start putting a lot more trust in GitHub itself. So I don't think it adds much more to take this approach over some alternatives. So it's really that we're trying to like funnel users towards using their Ethereum identities and ECDSA keys that they use their Ethereum addresses.
Okay, as a second question, sorry for that. I saw in the specs that the contribution, I mean, I checked the contribution file and I saw that the signatures are stored in contribution file. And however, it is noted in the spec that the signatures are recommended. It's not an obligation as far as I understand. So why is it so? Why is it?
So that's it's cool that you notice is the in-depth thing. When earlier I was mentioning writing your own crypto implementations, what you need to get working there is elliptic curve multiplication in G1 and G2 for BLS 12381. In order to do a signature, there's an extra step that's required, which is to be able to do hash to curve, which turns out is a lot of extra work to do on top of all this extra thing. So it's just supposed to encourage people to be able to write their own implementations, and also that some of the crypto libraries that exist out there, particularly in the academic space, don't necessarily support these signatures. So it just made it easier for everyone to not require it. And then if you decide to write your own implementation and go down that route, then like you know you're doing this at a slightly reduced level of being able to prove to other people that this was your contribution. But if you're using the website that will be hosted at ceremony.ethereum.org, or most of the mainline implementations, then these signatures will happen by default and are not really optional.
I see. I'm sorry, so just one more question, and this is the last one.
Okay.
Okay. In the spec, I also saw that a handover takeover process between the sequencers, as far as I understand. And if there will be multiple sequencers in the future, I mean, in the special contribution phase, who will sequence the sequencers? I mean, who will be the next sequencer and who will decide it?
So I think there was maybe an earlier version of the spec or a remnant from an earlier version. But the current plan is not to have multiple sequencers. So there is just one sequencer, and the idea is that given enough time, that everyone should be able to get their contribution in, and should be able to that's enough time that if there are problems with the sequencer, that we should be able to debug it or point it out, at least as a community, and then handle those use cases. So the additional complexity of passing around between multiple sequences just didn't seem to be worth it.
I see. Thank you very much.
Sure. Thanks for the questions.
I have an extra question. Have you heard about any other project that is planning to leverage the powers of tau that will be calculated for their own project? So like considering they need the same kind of amount of powers, maybe they can, if they trust the Ethereum ceremony, which makes some sense because if they are building on top of Ethereum, you kind of should do that, because if that breaks, everything breaks. So it may be interesting. I know if you have heard about anyone planning to use the result of the ceremony for other projects.
So I haven't heard of anyone else. And I think the issue here is predominantly what you mentioned, and it comes down to the number of points. So this ceremony is very small in comparison to most of the other ceremonies that have existed before. And that's because of the needs of 4844 are very small. So projects like Perpetual Powers of Tau, which are over a different curve, but ignoring that, the idea there being that like we could have lots of people contributing over time and have this like Uber setup that many people could use, like have so many points it becomes hard to run. And so the approach of this ceremony is like to have the minimal or a fairly minimal set of points that are only really useful in this KZG context or 4844 context specifically. So it's like a bespoke set of points. So people are welcome to use it. I think it'd be a very sensible thing if it matches someone else's use case. But I think outside of these kind of commitments, I think it'd be fairly hard to do.
All right. I think I have a few more questions. Those are not very complicated. I mean, like not very technical, but on a high level, I'm just curious to understand about a few details of it. You mentioned about ceremony participants. Ethereum client developers are obviously the invitees of that. Who else is invited to participate? Are you looking for infrastructure provided from Ethereum, or do you think that participations of other L2 blockchain developers could add value here?
So when I was using the word participant, I mean someone who's going to contribute towards the ceremony. So that's hopefully anyone within the Ethereum community. But in terms of like writing your own implementation, then that really is anyone who thinks they could extract some use out of the Ethereum ecosystem or out of what EIP 4844 could provide, and has an afternoon or so spare. Nothing like this is all as per, I guess, normal Ethereum protocols or standards. This is all written in the open, all with public specs, and there are no special gating that's happening here. So it really is up to whoever would like to participate or contribute in whichever way they want to get involved.
That is awesome. My next question is about how to contribute. You mentioned about using a sign-in with Ethereum. So are we using the proposal 4361 sign-in with Ethereum, which is available on EIP repository, or is it just like connecting with a wallet?
So it is that proposal, but it's I guess it depends on what interface you're using to work with a ceremony. So I guess for most people that'll be the website I mentioned. So if you go there, the process is first to collect some entropy. You're going to move your mouse around a bunch. You're going to type in some secret, and then it's going to ask you to sign in. And there you're going to connect one of your, well, you connect a wallet that meets the minimum nonce requirements, and then the sequencer is going to do check that you meet these requirements. So it is using that EIP under the hood as like the communication standard. And if you're writing your own implementation, you're going to be interested in something like this. But sign-in with Ethereum is a very easy thing to use, and it's part of why it's nice to use in this case is that it's a very simple OAuth system, which if you're using pretty much any common web tooling should be able to interface with that. So no matter what your language is, you should be able to find a way to do that. And there's not really a standard you have to implement, but you do need to be able to export a signature to be able to sign in.
That's very interesting to know. Like we are trying to make use of all the available standards and protocol in the Ethereum ecosystem to build up something new on top of that. For people who aren't aware of 4361 sign in with Ethereum EIP, we do have an episode on PEEPanEIP with the authors. The episode number is 61. Please check out and have more information about the proposal. My next question is about threats and attack. when we are talking about trust, that means there is existence of threat, and you did talk about some of the breaking points for the trusted setup. I vaguely remember a recent tweet about an attack on KZG's setup on Twitter. If you are by any chance aware of it, would you like to share what that attack report was?
Not off the top of my head aware. There've been many people who've mentioned things. Do you have a link, or do you know a summary?
No, I'm also not very clear. I just remember a comment like, if trusted setup cannot be trusted, the attack is there. Nevertheless, we will try to find what is the basic issue over there.
Yeah, so I mean, many people have, like, there I guess two camps that these seem to have like these concerns have fallen in thus far. One is around just the idea of trusted setups and the trust in general, and how do you make sure this is safe, and concerns about that, which I think are very valid to discuss, and is something that as a community we need to consider, and everyone should be monitoring the ceremony carefully to see that this meets our standards, and that there isn't funny business happening, and that kind of thing. And then the second is legitimate concerns about the safety of the ceremony. I don't think we've had any real ones of those. There've been some misunderstandings of the spec, and in the early days, some details of this weren't correct. There were bugs, but now that this is matured a bunch, it's been audited twice, and we have a bunch of implementations. I don't think that's the case anymore, or at least I'm not aware of that.
All right, that's really good to know. My next question is about audit. I vaguely remember about the mention of audits, like a cryptographic audit and sequencer audit. I think I found something on the roadmap of it. Would you like to maybe talk about the scope or the key highlights of these audits, and if there were any fixes that were done based on the recommendations?
Yeah, sure. So we did two audits. And the first was the SecBit, the idea being there that was a crypto audit, and to dig into the specifications. We didn't really have, we had some early code written of implementations, but the idea here was to find the bugs in the specs, because if those exist, then that's going to translate into all high levels of the stack. They've audited a bunch of ceremonies in the past, so it seemed like a good team to do so. They didn't find any major issues there. Some minor typos and some bad references and that kind of thing. But in terms of the actual core logic, there wasn't anything that needed to be addressed. And then the second audit, which finished up at the end of last year, was by Sigma Prime, who have a bunch of experience auditing crypto stuff, and Rust code, which is what the sequence is written in. So what they were looking at is, again, the crypto was, that the specifications were reasonable, and then that the sequencer was written in a way that it wouldn't be doing, it wouldn't censor, or it's unlikely to crash, etc., etc. And then finally, that the primary website didn't have any major issues in it either, because if that's how most people are going to contribute, a bug in that would potentially invalidate a lot of contributions. I think the findings, there were one or two findings. The report is available, but they're the things that were found were mostly on edge cases. So as I said, the smallest ceremony size we have is 4,096 points. But if you were to do a hypothetical ceremony where using only 1 point, then there was like an off by one error that could cause the ceremony to crash. And cases like that, which are like good to address for a robust code base, but none that caused us to worry about the security of this or the safety of the ceremony.
That's very valuable piece of information. I'm really happy to see that there are a lot of documentation available regarding KZG ceremony, so people can educate themselves. It's time to wrap up. Is there anything that you would like to add or share with the Ethereum community?
I think mostly that this is something to seriously consider, because this is an important part of Ethereum's security model moving forward. So I think it'd be cool if everyone thinks about like how this plays into that, and whether they feel comfortable with the way this is approaching. or that this is happening. I think on top of that, the making sure as many people as possible contribute. So contribute yourself. Encourage those around you to do so that we can have many people contributing to like help distribute these this trust amongst as many people as possible. And that should hopefully lead us to have the most secure ceremony possible, which I think is something that everyone wants here. Yeah, I think that's a summary of everything.
Like many others out in the world, I have my eyes peeled on blockchain scalability solution. Best wishes for the KZG ceremony starting on 13th January. Carl, thanks for joining us today to talk about KZG ceremony and its roadmap. I suppose that's helpful for many developers and hobbyists who would like to make a contribution. And on this note, thanks to everyone watching or listening to this non-EIP special episode. Should you have any question, let us know in the form available in description or leave a comment or reach us at eCatHerders Discord. Check out description for links to useful resources and guest Twitter to follow. We'll be back with another interesting Ethereum topic, so stay tuned and keep sharing your love with Ethereum cat herders. Cheers.